discuss today about KCL and KVL, okay, which is known as this KCL is known as Kirchhoff's current law, and this KVL is known as Kirchhoff's voltage law. So these two laws are basic law of electrical engineering. There are so many laws are there, but these two are basic laws in electrical circuit. So any electrical circuit can be analyzed with the help of these KCL and this KVL. Okay, so we'll go one by one. Okay, but before starting of KCL and KVL, we need to know some terminology related with electrical circuit. Okay, so let's see. So first is what is node and what is branch. Okay, so as you see, node is a point where two or more circuit elements are connected. Point two or more circuit elements. Now circuit element means either it can active or passive element. Active or just wait, active or passive element. Now active element means this is either voltage source or current source. Okay, it may be AC, maybe DC. Now and these passive means either resistor or inductor or capacitor. Okay, so two or more circuit element means either active element or passive element, where more than two, it may be more than one, it may be two, maybe three, maybe four. Okay, so this is the node uh, in a electrical circuit. Okay, it may be resistor, maybe inductor, maybe capacitor, whatever may be, but this is the junction point in electrical circuit where more than one circuit element are connected, either active or passive, as it is shown here. Now what is branch? A path that connect two nodes, something like this. This is suppose one node, this is this is one node, and this is one node. Okay, one node means you may ask there is no circuit element connected, but suppose there are some element connected here. Okay, for time being assume. So this is one branch, connect two node, and this is another branch, connect two node. Similarly here also, this is one branch, this is one branch, this is one branch. Okay, so this node and branch is basic terminology. Okay, and now before these Kirchhoff's laws, we want to know loop and mesh. Okay, so loop and mesh, so there is two term. Okay, if I write loop and mesh. Okay, so basically loop means what? It is a closed path. Okay, and mesh is basically, it is a closed path, but there will be no closed path inside this mesh. That means it is a loop, it is a loop where there is no other loop inside it. Okay, so just let me give an example. Just draw a circuit. I will draw, suppose, a circuit here, and I will explain to you. Suppose I will draw a simple circuit here. These are resistance. Okay, simple one. Suppose, for example, suppose. Okay, now loop is closed path. So this is, so this is loop. Okay, this is closed path. Similarly, this is also closed path. Okay, but this is also mesh. This is also mesh. Okay, why? Because mesh is a loop where there is no other loop. So in this loop, this is in this case, this is, there is only one loop, so it is a loop and it is a mesh. Similarly, here also it is a loop, it is a mesh. But if I, but just use other color. Suppose if I start from here and come back here, this green line or green color, this is a loop. This is a loop, but not mesh. Why? This is a loop, but not mesh. Why? Because loop, it is a closed path. But why not mesh? Because in this loop there are two other loop inside it. Okay, so that's why uh, this is a loop, but not mesh. So from here, what we can conclude? We can conclude that every mesh is a loop. Every mesh is a loop, but every loop is not a mesh. Means every loop, sorry, every mesh is a loop. Uh, every mesh is a loop, but every loop is not a mesh. Okay. Now, now come Kirchhoff's current law. What is Kirchhoff's current law? The algebraic sum of all currents entering any node in a circuit equals 0. What it say? That means, if suppose this is water pipe, suppose this is water pipe, and from here there are two paths. Suppose water is coming from here, for example, water is coming from here and it has two paths. Okay, so this is incoming, this is outgoing. Now I am assuming that there will be no loss of water. Okay, ideal case. So what will be the case? If the amount of water entering at this point will be equal to some water will be passed through this line and some will this. So the sum of the water which is coming through this line or this pipe will be equal to the sum of water at this pipe and this pipe, assuming there will be no loss of water. Same case Kirchhoff says, the current, the incoming current, something like this. You can see, if this is your node, the sum of incoming current equal to sum of outgoing current. This is easiest statement. Means if you see direction, this I2 is entering this I1 is entering. So here I1 plus I2, this equal to the sum of current leaving through this node, this I3 plus I4. Okay, this is one case, that algebraic sum of all currents entering at any node equal to, means sum of current entering through a node is equal to sum of current leaving through a node. And this one version is, if I say the algebraic sum of all currents entering any node. Algebraic sum means, suppose if you say current means it will magnitude as well as direction. So if you see, uh, these two are in opposite direction, means these and these are in same direction, these and these are in same direction. So if I take, suppose incoming current as positive, I will take outgoing current negative, or if I take incoming current negative, outgoing current will be positive, whatever may be. So if I take, suppose incoming current positive, for example, suppose if I take incoming current positive, so it will be plus I2, incoming current plus I1. And if I say, suppose take outgoing current is negative, so if I take outgoing current is minus I3, because it is outgoing, so I will take minus, and similarly I4. So algebraic sum means taking the reduction into account. Algebraic sum of all currents entering into node is equal to 0. Now if I take this equal to 0, and if I manipulate, it will become same. I1 plus I2 equal to I3 plus I4. So whatever is easy for you, you will go for it. Okay. Okay. Now, this next is Kirchhoff's voltage law. Kirchhoff's voltage law is what? Algebraic sum of all voltages around any closed loop is 0. Algebraic sum of all voltages around any closed loop is 0. One thing, this Kirchhoff's law based on conservation of charge. Keep in mind, this may become as a Viva question or any MCQ question. And this KVL, conservation of energy. Okay, because we know energy can neither be created nor be destroyed, it can only be transferred from one form to another. So what is KVL? The algebraic sum of all voltages around any loop in a circuit equal to 0. Okay, we'll see next slide explanation. Okay, this is, I think I have already told you. This is already told, sum of these entering current equal to leaving current. Okay, if you take this, I have already mentioned, you can take anyone, either incoming current positive or outgoing current positive, and vice versa. If you take incoming current positive, you will take outgoing current negative, and if you take incoming current negative, you will take outgoing current positive. Now, okay, so suppose this is an example, Kirchhoff's current law. I need to find, suppose branch current. Okay, here I will not find any value, just I will show you how to write KCL. Okay, you can see, this is one node. Okay, why? Because this circuit element active voltage source, and this is resistor. So two element connected at a point, so this is a node. Okay, similarly this is also a node, because three resistor connected at this node, it is a node. Similarly this is also a node, because the two resistor connected at this point, so this is also a node. Now this is also a node. So actually there are total four nodes, 1 2 3 4, and now these three are same. Okay, if I take this is, and this is, these three are same. Why? Because there are no element, no circuit element are connected, so these three are same node. So that's why this is common. Normally we call it a reference. Okay, so in any electrical circuit, if someone says there are total n number of nodes, suppose total n number of nodes. Okay, so out of this n, one will be one node. This is one node will be reference, will be reference node. So we need to find voltages of n minus 1 node. Okay, because reference node is 0, reference node voltage is 0. So we need to find uh, n node, n minus 1 node voltage. Okay, Okay, so now if I say what is the voltage at this node 1, what is the voltage at this node 1? See, uh, voltage source is connected, 3 volt voltage source is connected between node 1 and reference. So this voltage at node 1 is 3 volt. Voltage at node 1 is 3 volt. Okay, so as 3 volt a source is connected between this node 1 and reference, so voltage at node 1 is 3 volt. Okay, okay. Now suppose if I take this current is flowing from this left node 1 to node 2, and suppose if I take current flowing from this reference node to node 2, and this current flowing from node 2 to node 3. If I, this is assumption, okay, you can take any direction depending on, I will write this equation KCL, but at the end of the day, if your correct equations are correct, you will get the same result. Okay, so at node 2, if I apply KCL at node 2, what is KCL? Sum of entering current entering through node equal to sum of current leaving through a node. So in that case, what I will write at node 2, entering current is IR1 and IR3. So I've written IR1 and IR3 equal to what is the current leaving? IR2. So I've written IR2. Now what is IR1? We know. Suppose if this is a resistor, suppose this is V1 voltage, this is V2, this is resistance R, suppose this is current I. We know current flows from high potential to low potential. So I can write I equal to V1 minus V2 by R. So here I R1 equal to V1 minus V2. So I don't know the, so V1 voltage at node 1 minus V2 voltage at node 2 by 2.2 K kilo ohm. Okay, plus what is IR3? This is reference node 0. So V0 is voltage at reference. So this is 0. V0 is equal to 0. Okay, now V0 is 0. But here I have specifically mentioned V0. Okay, V0 on this V2. So current is flowing from this to this side. So V0 minus V2 by 1K equal to IR2 V2 minus V3 by 3.7K. Okay, so this is the way you can write KCL at node 2 and node 3. What is node 3? This current equal to this current IR2 equal to IR4. Okay, so what is the current flowing from this side? V2 minus V3 by 3.7K equal to what is the current? V3 minus V0, because voltage here I have taken this V0. Here I have taken V1, here I have assumed V2, here V3. So V3 minus V0 by for 4K. This is the way you can write KCL, and you will do calculation. When we will do numerical, we'll see, we'll do calculation and we'll find out values. Okay, but this is the way we will write KCL. Okay. Again, I am saying these are the assumption of direction taking. If you take IR3 flowing from node 2 to 0, according to your equation will change, but at the end of the day, you will get the same result. Okay. Now, what is Kirchhoff's voltage law? I have said the sum of all voltages around any closed loop is 0. Okay. Now, what in that case, what will take? Simple. I will take passive sign convention. Okay. Passive sign convention. What is that? It says, it says, um, it says if current is entering through positive terminal, it will absorb power, and if current is entering through positive terminal, it will absorb power, and if current is leaving through positive terminal, it will supply power, and uh, and if current is leaving through a positive terminal, if current is leaving through a positive terminal, it will supply power. Okay, it will supply power. So that's why if I have suppose resistor, if current is entering through this terminal, if this is plus, this is minus, this is R, this is V, I will write V equal to plus I into R. Okay, and suppose if current is entering through, suppose for any reason current is entering through this terminal, and this is suppose minus, this is plus, and this is R suppose V, so we'll write V equal to minus IR. Okay, okay. Now see, if I take current direction, so current is entering through this terminal, so I will take this is plus, this is minus, because resistance nothing is mentioned, so resistance will absorb power, I know. Similarly current is entering, so this is plus, this is minus. So if I write here, suppose if I start from here, okay, if I start from here, okay, this is suppose I1, this is suppose I2, both are clockwise, so this is I1. So in loop 1, suppose in loop 1, this is loop 1, this is loop 2. In loop 1 current is entering through plus terminal, so I will write plus I1 into R, and now I am coming here and I2 is here, both are opposite direction. So if I take I1 is, suppose I am taking I1 is more than I2, so it will be plus, it will be minus, so it will be I1 and I2 both are opposite direction, and I am assuming I1 is more than I2, so here I am taking the direction positive for I1, so plus minus, so it will be plus I1 minus I2 into R, and again I'm hitting, this is plus terminal battery, this is minus, hitting minus V1, so minus V1 equal to 0. We will get the same result. Okay, we get the same result. Now if I write at loop 2, if I write at loop 2, suppose I'm starting from here, so I am hitting plus terminal of R2, so I'll write plus I2 into R2, this is R1, okay, this is R1, I2 into R2, and this is plus of battery, so plus V2. Now again I am coming here. Now if I'm the I will this plus and minus will remain same. Okay, so here I am taking I2 is I2, direction of I2. So here what I am taking I2, so I2 minus I1, when I am considering loop 1, loop 2, so I'll take I2 minus I1, and this is hitting minus terminal, so I'll write minus I2 minus I1 into R equal to 0. Okay, if you have any confusion, you can take uh, this one I1 minus I2 into R. If I take minus common, so it will plus I1 minus I2 R, so anything you will get the same result. Okay, uh, I2, so when I2 is considering, this is hitting minus terminal, so I2, both I2 and I1 opposite direction, so minus of I2 minus I1 into R. And when this loop 1, this is I1 and I2 opposite direction, this is plus, so plus I1 minus I2 into R1, you have 0. So anything, anyone you will consider will get the same result. And second is this is second point is you have seen this direction, means in this loop 1 and loop 2 I have taken both the current direction as same, means clockwise, but it is not mandatory. You can take the direction at loop 1 clockwise and loop 2 anti-clockwise, accordingly your equation will change. This plus minus sign will change, but you will get the same equation. Okay, you will get the same equation. We'll see in a numerical when we'll see next video. But this keep these things in mind, that it is not mandatory to take the current direction in the loop in the same. Okay, I can take, suppose in loop 1 clockwise, in loop 2 anti-clockwise, anything. Okay, uh, accordingly your sign convention will change, and but you will get the same result if your sign convention is correct. Okay, so this is whatever I have told you, and this is the example we'll solve in the next video. Okay, this is example we'll solve in the next video. Okay, thank you.